This is the question number 37 of GATE 2014 Metallurgical Engineering. The question is, assume that Sievert's law hold for the solubility of hydrogen dissolved in a thin metal foil. If the partial pressure of the hydrogen in contact with the foil is increased by a factor of 4, the solubility increased by a factor of. So, what is the Sievert's law? So, Sievert's law states the solubility of diatomic gases, as example hydrogen, nitrogen, oxygen, etc., in a metal surface is proportional to the square root of the partial pressure of the gas at a given temperature. So if we write the Sievert's law in the mathematical form, so it will be, let's say if we write in the form of in case of the hydrogen, it will be the dissolved concentration of the hydrogen will be equal to the K is a constant, into root over of partial pressure of hydrogen. So basically how we are getting these equations? We are getting, like, let's say if you consider the atomic molecular hydrogen is there, hydrogen as is gaseous form is there, it is getting dissolved in a metal surface as a atomic hydrogen. So 2 mole of atomic hydrogen. Now if you write the K equilibrium for this reactions, it will be concentration of hydrogen whole to the power 2 divided by the partial pressure of hydrogen. So if you rearrange these equations, we will get the concentration of the dissolved hydrogen is equal to K equilibrium whole to the power half into root over of pH2 or K into root over of pH2. So now it is mentioned that if the partial pressure of the hydrogen in contact with the foil is increased by a factor of 4, the solubility increases by a factor of. So now, as we have already seen, that the dissolved concentration of the dissolved hydrogen is proportional to the square root of the partial pressure of the hydrogen. So now if the partial pressure is increased by a factor of 4, so the concentration of the dissolved hydrogen will increase by a factor of 2.